Hi guys, today I will be showing you how to factor. We will be going from easy to challenging. This math skill is very important to master and is a prerequisite to many courses. So let's start. We have this example, 13x plus 13. Now we always look for the common factor. So the common factor here is 13, and we divide each term by 13. So 13x divided by 13 is x, and 13 divided by 13 is 1. And so this is our final factor. Now, let's go on to a different question. 2x squared plus x. The common factor is x, so we will take out an x outside, open the brackets, and we say 2x squared divided by x is just 2x, and x divided by x is 1. So this is our final factor. Now if we move on to a different question. Now what happens when we don't have a polynomial that has a common factor for every term? So let me give you an example. We could say x squared plus 7x plus 6. Now there is no there's no factor for any of these terms that match each one. So x cannot be divided here because the 6 does not have an x, and 6 and 7 do not have common factors besides 1. So what we do here is we take this term and this term. We take the coefficient of the first term, which is actually this invisible 1. We take the 1, we multiply by 6, multiply by the other term here, and we get 6. And then we take this term, we can just write it down over here. So what we have to estimate now is we have to say, not estimate, we have to say what two numbers multiply to 6 and add up to 7. Well, this case is very easy. It's just 1 and 6. And remember, the numbers have to be the same. Right, so 1 times 6 is 6, and 1 plus 6 is 7. So now what we do x squared, we basically open it up. So we say plus 6x plus x plus 6. Notice that these two will add up to that number, the 7x, because 6x plus x is 7x. So now we factor. We can rewrite it again just to make it nice. X squared plus 6x plus x plus 6. Now we will separate them. So we'll go like this. We'll add 2 brackets around each one. And we factor this one, and we will factor this one. So the common factor of the first bracket is x. So we take out x, and x squared divided by x is just x, and 6x divided by x is just 6. So then we can close those brackets. Plus, what is the common factor of the second term, x plus 6? Well, the common factor is just 1. So we just take out the 1, and we say x plus 6. Now, if you did not get a number that is the same on both sides, so that means the x plus 6 and the x plus 6 must be the same. If not, then you have done something wrong. And sometimes it's just not factorable, so you have to make sure that it comes out that they are the same. So then you can write out the x plus 6, and then you can do x plus 1. Now notice why this works, because here we have an x and it's multiplying to this whole term, and here we have a 1 that's multiplying to this whole term. And the same thing here, x is multiplied by this whole term, and 1 is multiplied by this whole term. So this is your common factor, is your final factored form. Okay, now let's move on to another question. Now this is another term. This is called difference of squares. X squared minus 1. Now there's a trick for doing these type of polynomials that have perfect squares. It's called difference of squares. And okay, so we know that the square root of x squared is x, and the square root of 1 is 1, and this is x. Now, any numbers like these that have a perfect square, namely the x squared, the 1, 16, 25, all have perfect squares. From there, you use these two numbers to, you put them in brackets. So you now will start off with x, you take the first square root, and you add it to the second one, and then you take the first square root and subtract from it the second one. Now, if we were to expand this, we would go like this, x squared, and then we can go minus x, and we do the same thing over here, 1 times x plus x minus 1, which gives us x squared minus 1. So whenever you have these type of things where there is a perfect squares with a minus in between, then you can do this trick. Now I'll give you another example, which will help out, I hope so. Now, if I have a number like so, 9x squared minus 16y squared. Now, we can see that this has a perfect square, because the square root of 9x squared is 3x, right? Because 3x times 3x, we have the 9, and then we have the x squared. And 16y squared, we could say that we have a 4, right, from the 16, so we have a 4, and then the y squared, the square root of it, is just y. So we have 2 1s. Now we do the same trick. We do 3x minus 4y multiplied by 3x plus 4y. Now when we open it up, we have 9x squared plus 12xy minus 12xy minus 16y squared. Notice how these two terms cancel out. We can move on to another question. And now notice that this does not work when it has a positive. If we have x squared plus 1, there is no factor for this equation. It is not possible to factor. We could try. We could say that we could do x plus 1 even, and we could say x plus 1. And notice how this gets you just x squared plus x, because we're crossing them over, and then just plus 1, which gives you x squared plus 2x plus 1. I'll just make that nice, which does not equal this. Now, remember that if you have a number like so, minus 25x squared plus 36y squared. Now, the negative is not in the middle, right? We have a positive in the middle, but we still have this negative on this side. So what you can do is we can flip them. We can send this one to that side and send this one to that side, making it equal 36y squared minus 25x squared. Now from there, we find the square root of 36y squared. The square root of 36y squared is 6y. And from here, we have a square root of 25x squared is 5x. So what we can do now, we can say 6y plus 5x 6y minus 5x. Don't be afraid to move them around. It's allowed when there's an addition. Now we can start moving on to a little bit more harder problems that we can apply our knowledge of. So let's say I have 48 x squared plus 4x minus 24. Now, we always want to start to find the largest common factor. So the greatest common factor here, out of all of them, is 4. So we can actually start taking out the 4 here. We can do 4. We can divide each term by 4. So 48x squared divided by 4 is 12x squared. And 4x divided by 4 is just x. And minus 24 divided by 4 is minus 6. Now we can use our factoring trick. We say we take these two numbers, multiply by them. So 12 multiplied by minus 6 is minus 72. And then we have a 1 here, that invisible 1 before the x. So we can say what multiplies to minus 72 and adds up to 1. Now what multiplies to minus 72 and adds up to 1? You can do this by making out a factor chart, but from here we can kind of just see that it is just 9 and minus 8. 9 times 8 is 72. 9 minus 8 is minus 72. So 9 times minus 8. And 9 plus minus 8 is just 1. So now we can do 12x plus 9x minus 8x minus 6. Now you can factor. So take out the 3. Sorry, there's an x squared here. Now we can do 3x multiply, right? Because then we have a 4x here. 3x times 4x is 12x squared. And 9x divided by 3x is just 3. We take out the common factor out of these ones as well. So the common factor here is minus 2. And we have a 4x, right? Because minus 2 times 4x is 8x. And minus 6 divided by minus 2 is plus 3. Now notice how we got the same terms on both sides. So now we can finish off by saying 3x minus 2 equals 4x plus 3. That is our final factored form. But don't forget, actually, that we have the 4. Don't forget the 4. The 4 needs to come in, because without it, then the question is not the same one that you got. So don't forget those numbers whenever you're doing these type of questions where you take out a number first. Let me just get rid of that first. Okay. Now I have another trick for a different type of question. Say we have 81 x squared minus 198 x plus 121. Now, this question might seem hard because you now have to multiply 81 and 121 and finds out what multiplies to that number and also adds up to minus 198. But what we can see here is that this first term and the last term are perfect squares. So the perfect square of 81x squared is 9x. And here the square root of 121 is 11. But we have to verify one last thing, that this term, minus 198, is equal to 9 times 11 times 2. Okay, so we have the 9 from the 9x and that from the 11 here, which are brought in. And we don't forget that there's also a multiply by 2. And we do know that it does equal 198. So now all you need to do is take this term and this term and put them in a squared bracket. We can go 9x, and because we have a minus here, we'll bring it to here minus 11, and then just make it squared. And this is your final factor. Now I'm getting a little bit harder. Now this is a very hard question, so feel free to pause the video and try to do it yourself while I do it here. So we have x to the power of 12, x minus 4 minus x minus 4. So we see that a common term between all of them is x minus 4. So let's divide each one. So x to the 12 multiplied by x minus 4 divided by x minus 4 is x to the 12. And this one has an invisible 1 here, a minus 1. So we have a minus 1 here that multiplies to the x minus 4 to get you this term. Now we have a perfect square. We can't really do anything with the first term, but we can with the second term, x cubed, x to the 12th minus 1. This has a perfect square, and this has a perfect square. This equals 1, and x to the power of 12 is when it's being square rooted is x to the 6th, because we know that x to the 6th squared, you multiply these two terms together and you get x to the 12th. So we have x to the 6th and a 1. So what we can do, we have x minus 4 and x minus 6. We have that difference of squares number. We can do minus, and we have the plus, x to the 6 plus 1. And that gives you the x12 minus 1. But we can still go further. We can't do anything with this one. We can't do anything with this one. But we can do with this one. X to the 6th minus 1. This is a perfect square of x to the 3. And this one just has a perfect square of 1, like we had before. So we can do that again. We have x minus 4. Personally, I would write the ones that don't have anything available to be done with them, just to write them on the left so we can clear up space. Plus 1. And notice we can't do anything with the x to the 6 plus 1 because it has the positive sign, and we can only do it with a negative. And now we can use the difference of squares of this one. We can do x to the cubed minus 1 x to the cubed plus 1. Now we could go further with an x to the 3 because the square root of it is x to the 1.5, but there's no real reason to go into when you have decimal places. So this is your final answer. Okay, now I'm going to give another example. We have 18 x squared plus 84x plus 98. Okay, now we see that the greatest common factor out of all of these terms is 2. So we can already take out the 2. We have the 9x squared, because 18x squared divided by 2 is 9x squared. And we have the 84x divided by 2 is 42x. And 98 divided by 2 is 49. Now, inside of this bracket, we have the two perfect squares, 9x squared and 49. The square root of 9x squared is 3x, And for the 49, we have 7. And now let's check the middle term. Does it equal to 3 from the 3x, the 7 from the square root of 49, multiplied by 2? And we do see that it equals 42. So like we did earlier, you take the 2, now you can take the 3x plus 7, because we have that plus here, using the 2 square roots, and put it in a square. And that is your final factored form. Okay, so we have a couple more questions to do. Not much more. And now, what happens when you have two? If you have two variables, well, it shouldn't be that much more difficult. It's just sometimes confusing or annoying or scary, but there's no actual reason. It's really easy. When you have something like this, 3x squared plus 14xy plus 8y squared. Now, what we can actually check this out. We can do, like we did earlier, what multiplies to 3x times 8y squared? So 3x multiplied by 8y squared is 24x squared y squared. So we have to say what multiplies to those two numbers, 24x squared y squared, and adds up to that middle number, right? This middle number with 14xy. So I can actually see that this is a 12. We can say 12xy and 2xy. You want to use both of the variables. And here you have 12xy and 2xy, and you have both the same numbers, right? It's possible. We have a 12xy times 2xy equals 24x squared y squared, because the x is multiplied by the x, the y multiplies by the y, and the 12 and 2, giving you 24x squared y squared. And you have the 12xy plus 2xy gives you the 14xy. So from here, you can do 3x squared plus 12xy plus 2xy. Remember, we broke it down, and these two numbers do equal 14xy plus 8y squared. And then we bracket the two terms. Each two terms are bracketed. Now we can factor each one. We say 3x, because that's our common term out of the first one. We have an x, because 3x squared divided by 3x is x, and 12xy divided by 3x is 4y. And then we have, out of this term, we have a 2 and a y. 2y is able to be taken out of both of them. So here we just have x left and 4y left. And notice how these two are the same. So the actual final factor is x plus 4y. And then using these two numbers, 3x plus 2y, and that is our final factor. Okay, now I have a very difficult one. 2x squared multiplied by x plus 1 minus x plus 1 squared minus 2x plus 1. Now, we're looking for the common factor. The common factor here is x plus 1. So we'll write out x plus 1 on the side in brackets. And we write out each term that multiplies to it. So we have a 2x squared. Now here we have a minus x plus 1 squared. So we actually can only get rid of the only 1. There still is this full term here, right? Minus x plus 1, because it was squared and 1 went over to this side, at a minus 2. So we can rewrite it again, but expanding the second brackets, 2x squared minus x squared, because minus x, we're going to go to each one and open it up, minus x minus 2. Now we have x plus 1, and we have 2x squared minus x squared is just x squared minus x minus 2. Now we see what multiplies to these two numbers. So what multiplies to 1 times minus 2, and what adds up to here, the invisible minus 1. So what we do have here is minus 2 and 1. So minus 2 multiplied by 1 is minus 2, and minus 2 plus 1 is minus 1. So we have an x plus 1 here. We have x squared. Now we can write it out, minus 2x plus x minus 2. Okay, now we can do our factoring. We can separate the last bracket into another bracket. So we have, put the brackets, x cubed minus 2x plus x minus 2. And then here we can take out the big term here, which is x, and x minus 2 plus, don't forget the invisible one here, x minus 2. So from there, you can factor and write x plus 1, and then you have another x plus 1 here, right? Because you have the x here and the plus 1 here, x plus 1, and then you have that common x minus 2. So this is your common factor. You can also just write it as x plus 1 squared, because you have two of them multiplying, and x minus 2. It's probably preferable to write it like this, because it's as the shortest as possible. Okay, now we're up to our second last example. This involves using the difference of squares example. It's kind of challenging. You can do x cubed minus 3 squared minus 4x squared. Now we can see here that we have a common thing, which is that both of them have a perfect square. So the perfect square out of this one is just x squared minus 3, and this one just has 2x as its common factor. So we can write out x cubed minus 3 plus 2x multiplied by x cubed minus 3 minus 2x. Now you have these two terms here, and we should probably write it around so that the 2x is before the 3. So we have x squared plus 2x minus 3. And here we have x squared minus 2x minus 3. Now we have to do our factoring. So let's factor our first term. So we have to do here what multiplies to minus 3 and adds up to 2. Well, 3 and minus 1. 3 times minus 1 is minus 3, and 3 plus minus 1 is just 2. So now let's just deal with the first term, x squared plus 3x minus x minus 3. Now if we separate them, we have x squared plus 3x minus, we have actually a plus, and then plus minus x minus 3. And now we can take out from this term, and then we'll take out from this term. So x plus 3, And we'll take out a negative to make these two terms inside the positive. So negative, and then x plus 3. So from the first factor of x squared plus 2x minus 3, we get x minus 1 and x plus 3. That comes from our first term. Now let's move on to the second term. We have on the second term x squared minus 2x minus 3. So what multiplies to minus 3, but this time adds to minus 2. So we have minus 3 plus 1. You could say that minus 3 plus 1. Notice how they're different. This one is 3 times minus 1, and this is minus 3 times plus 1. So minus 3 plus 1 gives you that number. Now we can open it up. So x squared minus 3x plus x minus 3. Now we can take out a term from each of the two terms. So x minus 3 plus x minus 3. So then we have here the x, the invisible 1, so x plus 1 and x minus 3. So that comes from your second term. Now don't forget to add both terms together by multiplying them in your final answer. So we'll take the first term, x plus 1. Sorry, that's an x minus 1. Let me just fix that. X minus 1. And now here we have an x plus 3. This is all coming from the first term of x squared plus 2x minus 3. And then we have the other one, x plus 1 and x minus 3. So this is your final answer from x squared minus 3 squared minus 4x squared. Now we have our final example. It is basically the same sort of question. So you guys should pause the video and try to solve it yourself. Just a moment to find the delete button. Let me just delete it so I have some space to write my next. Select it, move around. Alright, fine. We'll just delete everything here. Okay. Now for the final question, you should probably pause the video and try to solve it yourself, because it'd be really beneficial if you're able to solve it yourself. And let's write it out. So x squared minus 5x squared minus 36. So here we have another difference of squares, right? The perfect square of x squared minus 5x squared is just term in the inside, x squared minus 5x. And this term here is just a 6. So we can do what we did last time. We have that x squared right in the term minus 5x plus 6 and x squared minus 5x minus 6. So now we have to factor each one. So we can do, we'll start off with the first one. We'll start off with this one. So what multiplies to 6 and adds up to minus 5? Try to pause the video to try to solve this question yourself. So it's actually minus 2 and minus 3. That gives us these numbers. Now, what we do now, we go x squared minus 3x minus 2x by expanding plus 6. Factor two terms, right? Minus 2x minus 3. Now for the first one, from the first factor of x squared minus 5x plus 6, we get x minus 2 and x minus 3. Now we do the second one. What multiplies to minus 6 and adds up to minus 5. Guys, just solve it for a moment. Okay, this one actually gives you a minus 6 multiplied by 1, and minus 6 plus 1 are the numbers. So we can go x squared minus 6x plus x minus 6. Now we can bracket the terms just like we did last time. We take out x minus 6. Remember, there's an invisible 1 here, so plus 1 x minus 6. And now we can have the x plus 1 and x minus 6. That's from the second term. Now we have to add them both together with the multiplication, because they can't be coming alone. So we put them together: x squared, x minus 2, x minus 3, multiplied by x plus 1, we have the second terms now, and x minus 6. So that is your final factor for x squared minus 5x squared minus 36. I hope you found this video helpful and beneficial to your math. If you would, please subscribe and like the video and share it with all your friends to really help grow this channel. I would appreciate it very much. Thank you.